Hello everyone, I am Yuvesh Menghare from Walchand College of Engineering, Sangli. Welcome to my internship project presentation on washing machine controller using PIC16 F8778, developed as a part of Emertxe embedded system internship program during May-June 2025. So let's move forward towards presentation. About the internship, as the internship name is Embedded System Internship by Emertxe Information Technologies for a duration of 1 month. Mode online with hands-on simulation using PICSimLab and coding on MPLAB X ID with XC8 compiler. So the internship goals are building strong foundation in embedded C programming, learn microcontroller architecture PIC16 F877A and how to program it, understand peripheral interfacing LED, keypad, timer, LCD, buzzer, fan, gain exposure to real-time embedded systems development, complete a fully functional embedded project as an outcome. So this is project overview. My goal was to simulate a washing machine using PIC microcontroller. It supports different washing modes, water levels, LCD messages, hand control, and buzzer alerts, all managed in real time using timers and interrupts. So the project objective is design and simulate washing machine using PIC microcontroller and handle real-time control for mode selection. Key features are mode selection like quick wash, normal, heavy, spin only and wash only. Water level selection like low, medium, high, maximum. LCD display show process stages like power on, washing, rinsing, spinning and completed. Buzzer alerts for start, end, errors or notifications. Hand control simulate the washing machine drum motor. Timer plus interrupt handling manages process duration accurately like wash, rinse, spin and many more. So this is project significance. Like why this project? Washing machine are a real example of embedded systems widely used in home automation. It demonstrates how microcontroller automate physical process based on user input. The project combines critical embedded system concepts like input handling, example keypad, output control, LCD display, buzzer, fan, process control using timers and interrupts, which is used for scheduling tasks. Provide practical experience in hardware interfacing, embedded C programming, and real-time process management. Next is what I learned. I learned C programming, learn how to structure code, use function, and manage variables in embedded C. Microcontroller fundamentals. Understood what a microcontroller is and how it controls external components. I studied PIC16 F877A, its internal architecture, I/O ports, timers, and how to program it. LEDs. Practice turning LEDs on or off using GPIO with multiple functionality. Digital keypad. Implemented output readings and differentiated short press versus long press logic. Here, I built confidence in embedded C, understood how microcontroller interface with components and program real-world peripherals like digital keypads, LCD, and timers. Let's move forward to next slide. Next is development tools and components. The hardware we use is microcontroller PIC16F8778, which is of 40 pin. Input devices 6 key digital keypad. Output devices LCD 16:2 C LCD for status display, but here we use 16:4. Buzzer for alerts, fan for motor simulation or drum operations. Software and development tools are MPLAB X ID, code development environment, X8 compiler, microcontroller C compiler, which is used for PIC family, PICSimLab microcontroller simulation tool. Here I use PIC, a powerful 8-bit microcontroller with multiple I/O timers and ADC. Key components include 6-key digital keypad, 16:2 LCD buzzer, fan using GPIO. So the next is very important block diagram of. Here's the visual breakdown. Inputs include keypad and optional temperature sensor processed by microcontroller. Outputs go to LCD, buzzer, and fan motor simulation. Modules like ADC, double EEPROM, and serial ports for offer optional expansion. Input sensors GPIO handles general digital input-output signal. I2C RTC EEPROM interface with real-time clock or memory over I2C. LM35, which is a temperature sensor, provides analog temperature readings. ADC, which is used to convert analog sensor inputs to digital data. Next is PIC microcontroller for processing and control. RS-232 enable serial communication with external devices. LEDs indicates system or status output. Buzzer provide audible alerts or notifications. Digital keypad used for selecting washing machine programs or controls. So this is the board diagram of PIC microcontroller. Here this is a PIC microcontroller and this is overall kit or a board used for simulation. Here we see these SSDs, 7 segment displays used for display numerical values or timers. This matrix keypad, multi-button interface for expanded input-out options. See LCDs display washing machine status, time and options. Next is embedded system. What is the embedded system? Here we use, but embedded system is nothing but microcontroller plus peripherals to all to perform specific tasks. Our embedded system is real-time control of washing stages, user interaction through keypad and LCDs, timer-based washing simulations, buzzer fan relays as output actuators. Next is development process. It requires understanding of washing machine flow, plan user interaction like program select, water level, start and stop operation. Component mapping is very important step. Map each hardware peripheral to microcontroller ports. Code structure design. Writing a code and distributing it into a function is very important to write code efficiently. State machine model. We first program, then we distribute in level, and we start and then run. Functions for each screen and states. Implementation and debugging. Timer based control. Keypad edge detection, short press or long press. We have both. We can use level or edge triggering, but here we use edge detection, which is nothing but edge triggering. See LCD message updates. Next is key implementation details. Power on, block display plus welcome messages, state transition, switch 4, short press scroll, switch 4, long press, go to next screen, timing control based on water level plus program selected, final run, runs timer, activates fan, shows status like wash, rinse and spins, completion, stop fan, activate buzzer, shows message. It is a state driven where each key press moves the user between screens, from program selection to water level and start or stop and washing execution. Each screen is modular and managed via flags and delays to ensure smooth transition. The washing machine flow begins with power on. Here we select the program, choose water level and start the wash. Inside the washing cycle, timer-based stages like wash, rinse, spins are shown dynamically. Once complete, the fan stops and buzzer alerts the user. What are the challenges I face during implementation of these projects? First is keypad debouncing. In keypad debouncing, initial key press detection was unstable. It is resolved by adding software delay and state-based detection. Here I use a for loop which is creating delay to avoid debouncing. Next is switch mode detection. Short versus long press. It is it is facing very difficulty in differentiating whether it is a short press or long press. But it is used using counter based logic in read digital keypad function. Here I set a specific time. Below this time it will be considered as short press and above this time it will be considered as long press. Next is timing accuracy. Delays I apply but they are not realistic initially. I fixed using timer to configuration and calibrated delays. Another one is state transition bugs. Sometimes screen didn't move forward, but it is corrected by reviewing flag updates. I check the while function there. The main problem is the final declaration of key is missing sometimes. I update that by reviewing flag updates and ensuring proper edge detection. Another is power on delay. Animation took too long, so I reduce delay duration for better responsiveness. These were challenges like key bouncing issues, timing mismatches, and logic bugs. I fixed this using flag based and input logic, delay tuning, and timer calibration. So, the next is testing and simulation results. All the testing done using PICSimLab, eliminating the need of physical hardware. Function screen verified. Power on animation. Washing programs ruling and selection. Water level screen with short and long press detection. Start and stop interface handling. Switch 5 and switch 6. Timer countdown and phase wise execution. Wash, after that rinse, then spin, and output is tested by fan, which is used for motor simulation, buzzer for completion alerts, LCD updates throughout the cycle. And these are the bugs that are fixed: key press debouncing, delay timing tuning, and state flag mismanagement. All the screens were simulated and tested in PICSimLab. Power on, scroll, input and output. These are the flow. The output action like fan on or off and buzzer alerts are also verified here. Next is real real-time workflow. Step 1, power on. Then user press switch 5, power on, animation starts. Step 2, program selection. User selects what program which he want to implement. Then switch hold short press to scroll through 12 washing programs, and long press that enters in next water level selection. Step 3, water level. Scroll between auto, low, medium, high, max. Step 4, start and stop. Switch 5 is used to start, and switch 6 gives the control flow of program back to program selection. Step 5, washing cycle. Timer based stages: wash, rinse, spin, fan and buzzer control. Step 6, completion. Final screen plus buzzer alerts. So next is project live demo. Initially power on screen with key press, program selection, scrolling, water level selection, start and stop prompt, washing machine simulation with dynamic time and functional display, complete screen with buzzer sound. So I want to show the demo of my project. Before demo, I want to show what software tools I use. This is MPLAB X ID where I do my code development. Here I write all code and distribute in all these files separately. And the main 2 files, which is washing machine function definition and main.c. This is the main 2 files where we used to write main functionality, and these are the header files, and these are the individual like CLCD, digital keypad. These are integrated in the washing machine project here. I use X8 compiler with this. So now let's move to project demo. So this is project demo. Here we are required 20 Hz frequency. Here I use 16 into 4 display, 4 lines and each line 16 characters. So we already see the functions of the keys. This is switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. We have to press these switches and see the functionality of what code we written there. So let's get started. So here first we have to load hex file from here. We load hex file here, and after that on LCD screen the screen says press key 5 to power on washing machine. So we press key 5. It shows powering on washing machine. It displays for some time and then automatically it moves to new screen where we have to select washing program like this. Here there are 12 options and we are we have to select one of the option to move forward. So we will select using switch 4. This is switch 4. We have to press for short duration and release. It moves to next option of washing program. Then we will select like if we select dedicates, then we have to press switch 4 for longer duration to get into it to select washing level. We will here we will press switch 4 for long time. See here we enter into a water level selection. In water level selection again I implemented switch 4. If I press it for shorter duration, it will move to next option like from auto to low to medium, then remaining ones. See, if I press switch 4 for shorter duration, it will move to low. And I want to deep dive into low. I want to select the low option. Then I have to press low option for more time. For we have to press switch 4 for long time. I will press switch 4 for long time. See, the next screen it open. Press switch. If I want to start the program, then I have to press switch 5 to start, and to stop I have to press switch 6. So let's start the program by clicking switch 5. Here I click switch 5. So for dedicates it start the program. So here the washing machine start, and in this condition washing machine start shows that fan is moving. So here if I press switch 5 here to start, and if I want to pause, then I have to press switch 4. Switch 6, it pause. If I press switch 6, it pause, and if I want to again start the program, then I have to again press switch 5, then I pause. So this is a here the timer function is implemented. It counts and shows first there was a wash option, then rinse, then spin, and it automatically moves. And I pause here. I want to start buzzer from here to see to hear the sound it shows. And before this, if I press switch 6, switch 1, first I want to start here. So it shows the program completed, and it automatically moves to washing program selection. There is one option for switch 1 I tried here, where this shows the door is open or closed depending on the timer, if it completes or it running. So this was the final project demo. I will again simulate this once. I want to preset from here, switch 5. Then I will select low. I will select low. For start, switch 5. It gets started, and I will show this switch 1. Door is open, please close the door. So I use this functionality here, and this buzzer get implemented after this washing happens completed. So let's wait for another 5 seconds. So program completed, remove closes. Is again back to this. So let's conclude our project presentation. So conclusion. Here I understood how embedded system control real-time application, gain hands-on experience in CCLD, digital keypad, timer, buzzer and fan control, learn state-based programming, simulated complete washing machine logic. In a summary, I understood the real meaning of embedded system, how it interacts with the world. Internship gave me confidence in embedded peak architecture and peripherals. Thank you, Emertxe faculties and mentor for amazing opportunity. I look forward to more embedded projects ahead. Thank you so much.